All right, let's dive into one of the most basic building blocks of networking, static routing. It's the simplest, most direct way you can tell your network's traffic where to go, and honestly, understanding this is key to understanding everything else. So let's get right into it.
Okay, so let's start with the most fundamental question there is. You've got this box, a router, and its whole job is to connect different networks. But how does it actually know where to send your data? Does it just figure it out on its own?
Well, the short answer is no, it absolutely doesn't. A router, right out of the box, has a very, very limited view of the world. It needs a map, and one way to get at that map is for you to draw it yourself, by hand.
And that really gets to the heart of our first big idea here, a router's blind spot. See, a router isn't all-knowing. By default, it only really knows about the networks that are physically plugged right into its own ports. Everything else, it's a total mystery.
So let's paint a picture. Imagine we have router A, and it's connected to its own little local network. And then over here, we've got router B, connected to a completely different local network. Now, they might be connected to each other, but each one only sees its own backyard.
And this is the whole problem, right? Router A knows everything about its own network, but it has absolutely zero idea that Router B's network even exists. It's totally in a blind spot. So how do we fix that? How do we make it see?
We fix it by giving it a manual map. That's the solution. Instead of waiting for the router to magically discover other networks, we're just going to step in and explicitly tell it, hey, to get to that destination, you need to go this way. And that right there is the textbook definition of a static route. It's a path that you, the network administrator, configure by hand. It's not smart, it doesn't adapt, it doesn't think for itself. It does exactly, and I mean exactly, what you tell it to do, period. And these qualities are exactly why static routing is so great, especially when you're learning this stuff. It's simple, it's super predictable, and that means you have total, absolute control. There are no surprises, which is perfect for small, simple networks or for situations where you know for a fact a path is never, ever going to change.
Okay, so that's the theory. Now let's get practical. How does this actually look when you're configuring a router? We're going to look at the exact command you would type in to create this manual map. And don't worry, we're going to break down every single piece.
Here it is. This one line of code is our entire instruction. I know it might look a little cryptic at first glance, but trust me, it's telling a very simple story, and it's broken into 3 parts. Let's decode this thing.
So the first part, IP route, that's just the command. It's you telling the router, hey, wake up, I'm about to give you a new direction for your map, for your routing table. It's as simple as that. Next up, these 2 pieces work together to define our destination. 192.168.2.0 is the network we want to reach, router B's network. And that subnet mask, the 255.255.255.0, is super important because it tells the router the exact size and boundaries of that network. It's like knowing the exact street address, not just the city. Together, they say, this is the specific place we're trying to get to. And finally, this last part. This single IP address is probably the most critical piece of the whole command. We call it the next hop. It tells router A, look, to get to that faraway network, all you have to do is forward the packet to the device at this specific address. In our case, that's the address of router B. It's the very next step on the journey. So we've typed in the command, we've hit enter. What happens now? Well, the router takes our instruction and immediately adds it to its internal map, what we call its routing table. And now we can actually go in and check that table to see our handiwork. And boom, this is what we'd see. See that little S at the beginning? That's our proof. It stands for static, confirming that we're the ones who added it manually. And the rest is crystal clear. To reach the 192.168.2.0 network, send the traffic via our next hop, 10.0.0.2. It worked.
Now, it is really important to understand the difference between this and something called a default route. A static route like the one we just made is like a super specific map to a single address. A default route, on the other hand, is like a big sign that just says, for any traffic that you have no other directions for, just send it this way. One is specific, the other is a catch-all for everything else.
Okay, so it all sounds pretty good, right? Simple, predictable, you're in control. But there's a catch, a big one. The very thing that makes static routes strong, their simplicity, is also their greatest weakness. What happens if the network changes? Or if something just breaks?
And here it is. This is the big limitation. A static route is, well, static. It's dumb.
It does not update itself. If that connection to router B suddenly goes down, router A has no idea. It won't detect the failure, and it will just keep trying to send all your data down a path that leads to nowhere.
And this quote from the source materials just sums it up perfectly. The static route you put in there remains. The traffic will fail, and the router does not even know it's broken. It's going to keep sending data into a black hole, totally clueless that anything is wrong. That's the trade-off you make for that total manual control.
Which, leaves us with this one last really interesting question. If these manual routes are so rigid, so fragile, why do we even bother with them? Why on earth are they considered the absolute foundation of how all routing works, from the simplest networks to the most complex corners of the internet? Well, it's because you have to understand this manual process first before you can appreciate everything that's built on top of it.